We're going to start off with what is a roll feed and why a roll feed. Now, back in the day, we have stamping occurring around 1870 in the modern day terms, right? With someone having a ram traveling up and down striking a part. It was actually a German manufacturer of bicycles, and he thought, hey, why don't I make this part out of metal, sheet metal, and stamp it the same way every single time. Now, fast forward to the 1900s, we have every single car panel, anything sheet metal related, made in this process of stamping. And throughout the years, what it has evolved into is that it's very cost effective to cut these parts out of a continuous strip that shows up in coil. We've mentioned this on other videos. Well, what's exciting about that is throughout the years there were things called air feeds and mechanical roll feeds. And then in the late 70s and early 80s we had the advent of the servo roll feed. Co-launched it in approximately 1982. And what we came out with was a Kevlar belt that controlled the stretch and the wearability of that, and gives us a precision down to about plus or minus 3 thou on accuracy, which is very good. And you can hit that over and over again. And that really is kind of where we are and what you're looking at in your plant right now. Now the next step up would be going into the basic makeup of a roll feed. We have this drawn out on the board here, and you can see that we have our controls cabinet, we have our feed cabinet, and I want to really start focusing on our feed head. Now the feed head is the heart and soul of this. It's what does control the motion of your material strip. And you have inside of this your two pinch rolls, your gears that transfer the torque from your servo motor, which is bolted, obviously belted, to your lower pinch roll that has, obviously the gears are sitting on this side. We have your catenary section with a warning sticker saying, warning, your co-machine may give you higher production than you've ever had in your history of your company before. The catenary section, if you guys remember, controls the slope of the material that entering the pinch rolls, or over on your straightener exiting your pinch rolls, right? So the whole thing behind that is to control the material so that it does not exceed what's called the minimum bend radius. And that is a formula based on the thickness, the yield, and the bend of that material that's allowable, the material type that controls the bend, which we call the minimum bend radius. You have as I mentioned, your feed cabinet. Now, not every feed of ours comes on a cabinet. Some of our feeds are press mounted. Inside of this, you have your piloting pneumatic valve, and then which controls the pneumatic cylinder living inside of your feed head, which connects to a pivot yoke that lifts your upper roller. We have adjustability on your cabinet here, as well as some options of a material support table and an oiler that can come on the backside. Pretty much standard options for this industry. And that is your basic makeup of your roll feed, your servo roll feed. The cabinet itself for the controls has your HMI, which is your human machine interface. It's just a touch screen that you can command your length and the other control features that you'd like to put into your setup. Inside of here lives your servo drive. Your servo motor, as mentioned, lives inside of your feed, but in your feed cabinet, your servo drive lives, the motion controller, if it has a PLC, and whatever else gagging equipment that you might have bought on your machine. The next thing I want to talk about is, what is piloting? Piloting is the ability to be able to center a part every single time. The purpose of that, or at least the problem it was trying to solve, is that when you put something into a die, it can move around as it's being formed. So these pilot pins, not only do they pick it up and then put it back into position, but they hold it into position while it's being formed, so that the part has everything centralized on it that you want. The shapes are exactly where they need to be every single time, and as that part carries through multiple stations, sometimes well over 20 stations, it does exactly what you want it to do every single time. That leads us into pilot and feed windows. So the pilot window is where your feed rolls, your pinch rolls on your feed located inside here, will open to release control of the strip and give it to your press, which obviously your die pins, your pilot pins are coming through on. So the theory behind this is that you want to have the ability to have a good baton handoff between the two. So you don't want it to be too late or too early. And we all know when you watch an Olympic race, when that happens improperly, which is very easy to do, the whole race can be lost, right? So your part can be absolutely ruined. You have to have where that die is starting to engage. A lot of people will tweak between that time of when the pilot pins actually just start to enter or when they're mostly entered, right? So you kind of figure out where that die is happiest, but in that time frame, you'll watch your press move very slowly, go inch it as slow as you can, and start to understand where in the degree window on your resolver or on your press controls is that die actually taking control of the strip. And that's where you start to begin your pilot window. So your pilot window, the beginning of it opens your roller. The end of it closes your roller, right? So it's just that simple. The moment it is ready to pass the material back off to the feed, which is something you need to know for sure, because if you don't, it'll slip forwards or backwards. So at the end, you keep inching that along until it releases it, and you'll see their strip move, and you want to make sure that you anticipate that. So you have that roller come back down right before that happens, right? The feed window is the same concept, but just inversely. You want that strip to be moved as soon as possible and in position right when it's needed. You don't want to go too late because sometimes you can start to get into the pilot window and it can start to really confuse things. So you want to give yourself the biggest time window possible or biggest degree window possible. Something that'll help you out with that is there's something in your HMI called your feed advise. Now your feed advise gives you the ability to put in your press strokes per minute. It gives you your part length and a couple other things, and it'll tell you what your acceleration and what your final speed is. And you simply put those in to your HMI, and it'll give you, once you understand what your window is, you also put that in there, and it'll kind of spit those numbers out so you know exactly how effectively you can do it. The lower the acceleration, the better to do the job, guys, because that will also incur slipping, right? You don't want to over-accelerate. It's like taking off from a stoplight very effectively in snowstorm, right? Think about if you've ever been in a snowstorm or in a rainstorm, and if you punch that gas, it's going to slip, right? So you want to have it come in nice and easy. So that's where acceleration comes in, and do that as low as possible. The feed advice helps with that, right? So the other thing I want to talk about is troubleshooting. You've done everything right. You set up your pilot window, you set up your feed window, and nothing is going as it should. You've put in 10 inches and it's coming in at 9.6, and you've micro adjusted it and it's still not coming in the way you want it to. You have a slippage issue. Now slippage is caused by a couple of things. Slippage is caused by feed alignment, it's caused by die alignment, it's caused by pinch roll pressure. So the first thing you want to check out is the feed alignment to the bolster. So how do you check that? You want to pull the guards off of the back of your feed. You unbolt those so you can see your rollers. You then either get a mechanical indicator out that'll measure to a distance, and you can repeat that distance on the far side and the near side of the roller. So far left, far right. Got it? So you want to make sure you do that. You can also use a laser, but you have to make sure that you are absolutely perpendicular to that bolster, or else you're going to shoot wrong, right? So, because what you're doing is you're making sure that those are square and parallel to the die bolster, right? So once you've found out that is exactly, let's just call it 6 inches on both sides, now you can move on to the next thing, which is your die alignment. Your dies have to be set up on center line to make sure that it's parallel. They have to be square to the bolster itself. So you want to make sure you check squareness with that. You can perform the same procedure if you have a close face to reference off of where you're indicating it in. But that material flow is very critical, because if it's off to the one side or off to the other side, what you have is you don't have the motion of the material matching the motion of the rollers, right? And you incur slippage that way. The other thing is the feed window and pilot window have to be dialed in like we discussed. And then pinch roll pressure. Your pinch roll pressure on something like this, it can come with what's called a counterbalance. So that counterbalance actually lives inside your cabinet, And if someone on third shift or second shift has rolled up and pumped that girl up, that can cause the material to not be have enough, that roller to not have enough traction on your material, because it actually can lift your roller, right? So you want to make sure your counterbalance is set. You want to make sure that your pinch roll pressure is set. You want to go until you start to edge wave that material, and then you back it off to where you can find it, and that's the maximum pressure you can run. You'll see the edge wave start to incur at a certain pressure. And once you get there, you know, hey, I've reached my limit. You want to back it off about 20%, and then that's about your sweet spot. You know, you can play within that, but that's a kind of a safe rule of thumb. So those are all of the things that help you set up your feed the best way possible so that you can have a repeatable job. You don't have to go back and check on line 8 because you know it's set up right and it's making good parts. Thank you for visiting Co, and we will see you in the next video.